Good afternoon, everybody. We're going to get started, right? Thanks for bearing with us. We were just going through a few things at the last minute there, just to make sure the event goes well. But welcome to the sort of third installment, right, of the U of M-Flint, U of M-Dearborn Collaborative Research and Networking Series. So today we're going to be focusing on educational innovation, artificial intelligence, and computer science, right? So, and these are sort of what you might think of as disparate fields, right? Because we want actually people to think more interdisciplinarily, right? So there's the option, right, of funding that might come out of this, right? If folks are able to find each other from the two regional campuses and find something they're very, very interested in doing, and sometimes just you never know what ideas are going to come out, especially even when you put two people in very different fields even together. So we're excited. I want to thank, first of all, I want to thank Rebecca Wren, Vesaliva Clark, and Armin Zakarian from U of M-Dearborn and Ken Sylvester from U of M-Flint. There was a lot of planning that went into all of this, right? And of course, I want to thank the chancellors, right? Chancellor Dutta from U of M-Flint and Chancellor Grosso from U of M-Dearborn, because they're putting up the funding that's sort of helping drive some of this, right? And it was an idea that came out, and I think it's a great thing, right? That we can learn. I've already actually connected with somebody from Dearborn, and I know other people have from the previous networking series. Okay. So what we're going to do is we're going to have some lightning speakers, right? Each speaker will talk for about 5 minutes. We'll try to stay on time, even though we're not totally there because we had the whole thing. But you know what I mean. But speakers, you guys will hear this sound, right, when it's 5 minutes, and I'll shut it off. And it just means wrap up. We just want to make sure we have plenty of time for people to meet each other during the breakout sessions that'll happen afterwards. So there's contact cards that I think everybody has received. And I think also Rebecca will put into the chat, so you can have a link so you can make sure to see everybody's interests, people that you might want to connect with. Also, there is another, the final networking series that'll happen 2 weeks from today on social justice and community engagement. So if you're interested in that, we welcome you back for that as well, okay? So I think that's all I have to say to sort of get us started. So I think what we're gonna do right now is sort of go into the lightning talk presenters. Our first presenter is Eunice Zetunka, an associate professor from mathematics and statistics at U of M-Dearborn. Eunice, take it away.
Thank you, Heather. I'd like to thank both chancellors and offices of research putting this event together. I'm excited to tell you a little bit about what we do in the mathematics department. Let me share my screen. All right, I believe you can see my screen. I ask my students to give me a thumbs up. Thank you, Wes, for doing that. All right, I'll be quick. I'll keep an eye on my timer too. I'll first talk about mathematics outreach we have in Dearborn, but before that, I'll try to answer a very quick question. What do mathematicians do? Mathematicians solve problems, and I'm a mathematician, and some people might argue that we have some problems in mathematics education. And I look at that problem as a mathematician too, and try to contribute to the solution. Here are a couple of reasons why people may claim there are problems in the math education in the United States. Many of you might be familiar with PISA, this international assessment program for 15-year-old students. And in the international rankings, here's the top 10 of the countries. United States is at number 38. Of course, there are lots of criticism to this assessment from different corners of the education world, and some of them are legitimate, but however we look at this, we can still keep this in mind as a data point. It's not going to explain what's going on completely, but it is a data point. I will present another data point that's more national than international. We have lots of folks at this forum from engineering units to engineering departments. And there are lots of articles in the literature relating importance of mathematics background in success in engineering and other STEM fields. We all, I think, agree that preparation in mathematics is a factor in building STEM workforce. So to have engineers, to have data scientists, to have people doing machine learning, all kinds of cool things that we will hear later today, artificial intelligence, strong background in mathematics will be an important factor. At the international level, it doesn't look like we are there. At the national level, it doesn't look like we are there. How about at the local level? I'll share one more data point from the local level. If you think of this bar as the need for mathematics teachers in the region, and if you are familiar with K-12 system, if you have family members, kids going to school nowadays, I'm sure you heard about the teacher shortage, and teacher shortage within mathematics is very significant too. So if you think about this bar as the number of mathematics teachers we need for our schools in Michigan, this is how much we have. We are about halfway there. Most of the mathematics classes around the region, they don't have a teacher currently going into the classroom to teach kids mathematics. And out of those 50% teachers in the mathematics classrooms, only half of them have a degree in mathematics or an adjacent field. So the situation is serious. 3 out of 4 kids, they don't see a mathematics teacher with mathematics education in their classroom. And this results in issues at the local level, at the national level, and at the international level. So what did we do in the mathematics department to address this? We started creating some programs for K-12 kids. We have math circles for middle schoolers on Wednesdays. We have math matches program for high schoolers on Saturdays. We have a summer camp for middle schoolers and high schoolers. And we also have a program with a nonprofit organization for elementary school kids. When we put all these together with our transportation cost, Center for Mathematics Education in Dearborn had an annual budget of around $200,000. We were lucky to get funding from federal agencies and foundations. I'll be very happy to talk more about any of these particular programs in breakout rooms down the road. I think I'm doing well with time. That's why I will skip this slide, because I was going to stop there if I wasn't doing well on time. So I talked about the lower end of the K-12 system, where we are trying to put students into this pipeline and get them through the pipeline. How about the students at the right end of the spectrum? Those students who are doing really well in mathematics, what can we do to help them to excel in mathematics adjacent fields? We have a program in Dearborn for those students too. We have this summer research program. It is funded by NSF, National Science Foundation, and NSA, National Security Agency. Our program is in mathematical analysis and applications. Each year we host 15 to 20 undergraduate research students for 8 weeks. These students are not only U of M Dearborn or U of M-Flint or U of M Ann Arbor students. We get students from all around the country. Here is the list of institutions that will be present this summer. I was just working on recruitment earlier this morning and this past week. So we get students from all around the country. They come to spend 8 weeks with our faculty members. And this program usually results in substantial research products from the mentors and students. Most of the student participants, they moved on to graduate programs in mathematics and all related fields around the country. Again, I'll be very happy to talk about the summer undergraduate research program we host in Dearborn or the outreach activities, both end of the pipeline. I'm excited that this network formed together to increase the collaboration between Dearborn and Flint. And anyone interested in designing something like this, it doesn't have to be in mathematics. We have folks from other areas too, artificial intelligence, computer science, whatever you can think of. I'll be more than happy to tell you more about our operation, more than happy to share our context in the region and at the federal agency levels and foundations. With that, I will stop here, but looking forward to meeting many of you in the breakout rooms too. Thank you.
Thank you very much. That was very helpful. The next speaker I know, and I don't know if she's going to talk about this, so I don't want to steal her thunder or anything, but she's also in mathematics and mathematics education. So if you guys, that's Laura McLean. So if you, Eunice and Laura are not in a breakout session together, I hope you will actually just seek each other out, because I think you'll have a lot to talk about for sure. So now, Laura McLean, she is an associate professor of mathematics at UM-Flint and also in the School of Education at UM-Flint. So it's sort of a split position. So I will leave it to Laura now. Thank you.
Well, thank you very much. Yes, as you just shared, I am in the Mathematics and Applied Sciences department, and I'm also in the Education department. And my focus is on mathematics education. So I very much appreciate the opportunity to come speak to you today. And today I'm going to talk to you about a program, or a curriculum actually, that we developed on our campus to kind of reform or think about teacher education differently. So Eunice talked about meeting the students themselves and bringing the students along, and we're more thinking about it from the perspective of the teachers. And so here on the right, you can see that these are some of our teacher candidates from past and some of my colleagues from past and present. And we were at a place-based education conference that we went down to. And so let me see if I can, there we go. And so this first slide that I've got here, really just to give some context about place-based education and place-based teacher education, because there are really two kind of components, right? Place-based education is a movement in education, right? And David Sobel, who's kind of the lead person, who's the grandfather, if you will, of place-based education, really talks about a way to bring the local community and the environment as the kind of basket, if you will, for learning all of these different things in schools, mathematics, social studies, science, whatever it may be. And it really emphasizes hands-on, real-world learning experiences, but within the context of the local community, right? Helping students to see what those problems are within their community, bringing community experts in to kind of understand and help students make sense of that, and then to learn these concepts that we teach in schools through that lens. And on the right there, you see this is from a local school in Flint. They have been working on a duck habitat project for years, and this is a publication that they got out of that. And these are some of the students that they work with. And so at the University of Michigan-Flint, we looked at, well, how do we prepare teachers to do this kind of work, right? And so this is some of our students in a entry-level seminar, right, where they were thinking about what are some of the salient and immediate questions and issues that you would have to grapple with as a teacher if you're going to be working on place-based education, and how does that connect to the local community? How can we bring the local community in to help us make sense of that? And on the right, you can't really see it, but it says humanizing education. So this was their project where they interviewed teachers and they met community leaders and they visited schools and they visited community events, right, to kind of help them grapple with this question. So it's really kind of two sides of it. We're really thinking about how do we prepare teachers to do that. And so one of the things I just wanted to talk quickly about is why is this important? And Eunice talked a little bit about it. So thank you, Eunice, for doing that. Teachers are leaving the profession. Eunice showed a nice graphic about that. These shortages aren't new, but certainly the pandemic has increased this number for sure. The teachers report feelings of isolation. They don't feel trusted. They don't feel like they have support. They feel like there's a disconnect from the kind of larger purpose, why they went into teaching, this calling, among other things. And so we posit that place-based teacher education, right, reconceptualizes this, that it allows us to work in tandem together, bringing schools and communities together. So it does help with that isolation, and develops trust amongst different stakeholders. So this picture was a picture. There's some students from UM-Flint here. We have the chief of police from a local township. We have some parents there. We have there's me right there. There's staff at UM-Flint and some teachers and so on. So it's just a nice way to kind of bring this together and really help our teacher candidates really see how this makes sense and how we can combat these things that teachers are feeling. And certainly that might not address all of the shortages, but if we can prepare teachers to go into the field and not feel isolated and know where they can reach out, that is going to help them stay in the field. And so one of the things that we have done is we've tried to start to study how to do this within a PBTE program, our own. And we really wanted to think about how we could understand how teacher candidates were experiencing that. And so I'm gonna skip this slide mostly, but we did start to study this and really think about this. And really the big thing and the findings is this last bullet where it says candidates are beginning to see the subjective nature of ideas early in their education. That's really important when we think about that, because we don't want teachers to go into the field thinking, oh, it's just black or white, it's just this and this, it's my way or the highway. But that when they're in conversations, when they're talking with their students and hearing their students' ideas, when they're talking with parents, when they're talking with community members, that everybody's bringing their own perspective into these things, and it really gets messy. And then it's really how do we help our candidates unpack this messiness and really go forward from there. So just at the end here, just some questions that, if you're interested in discussing with this in the breakout room, this is some of the questions that I and my colleagues have, right? How do we help teacher candidates develop this belief system? There's some that are kind of aligned with PBTE, right? How are their perceptions shaped of students in the community when they engage with community members? Number two, more longitudinal, right? Like, so how do we think about when teachers in the field, what are they doing that might be different than somebody who doesn't go through PBTE curriculum? And then of course, just in reform in general, like why is it now more than ever PBE and PBTE really of interest? Because there's lots of universities now and higher educations and community entities that are getting $1 million grants to do this work. And I think MSU being one of them, right, just recently has a huge grant to kind of study place-based teacher education. So, right, thinking about why that might be and what we can learn from that. And certainly this is something that we've been doing for a long time. And certainly we would love to connect with other folks that might be interested in doing that. And also trying to get out there and thinking about our own context and thinking about our own local communities and what that might mean for the communities that we serve, which are different than perhaps the communities that other institutions, other higher ed institutions are serving. So with that, I think I'm done. I don't know where I am on time, but I'm done.
Yeah, you're okay. I mean, speakers go a little bit over. I don't want to be disruptive with my little chime.
We're the mathematicians, Eunice and I. So when you tell us 5 minutes, Eunice is shaking his head. We do 5 minutes. So.
It's true. I could have chimed in there, right, and let you know that it had been time, but I didn't want to be disruptive because you guys were doing great, and I think you were keeping on time. I got a visitor. Sorry about that. Yeah, thank you very much, Laura. I appreciate it. So we have another assistant professor, we're going with assistant professor of computer and information science at UM-Dearborn, Zhang Song. He's the next presenter. Zhang?
Yep, can you hear me?
Yes.
Okay, thanks. So yeah, thank you for inviting me, and I'm from the CS department of UM-Dearborn. So my primary research focus is edge computing. So edge computing is an emerging domain. So compared with cloud, where all data is sent to the center of the network for processing, edge computing puts the resources close to the user, right? So that it reduces latency, and it saves the bandwidth for processing the data, for transmitting the data. However, we find out that edge computing, it features limited resources compared with the compared with the cloud, and also in different edge environment, the resources are really like not the same. So my primary research focus will be like how to create a runtime system to provide best effort edge services in pervasive edge environment that feature uncertain and limited resources. So this is, and then I'm also working on web services. So this is the from the Rapid API, one of the largest web service repository. So you can see like for flight data, they have a lot of web service that provide flight data. So how do we choose? If I'm a developer, how do I choose which one to use, right? So most of us choose based on the quality of service, like the latency of those service and the reliability of those service. But we recently found out that the quality of information is not being discussed. So whether the data provided by the service is correct, if it is fresh enough, if the service cover enough data, they are not being discussed, they are not being evaluated for software to use. So this is another focus, and I'm also working on project-based learning. So I designed a project-based learning module for computer network course, and you can see like in computer science courses, we usually have quite a lot of documents that we ask the student to submit, right? So for example, for software engineering, we ask them to submit like the design document, we ask them to submit the testing document, we ask them to submit a final report, right? So when you are facing a class of like 40 students, it is extremely hard for the instructor to review all the documents one by one. And by the way, one document can be like 50 pages long. So it is hard for the instructor to view all those documents one by one and then point out what is how the student can improve, what is the missing knowledge of the student, right? So, but that is critical for the student to learn to really learn by project-based learning. So I'm thinking of how can we solve this issue, right, by some computer science technology like text analysis, like analyze the unstructured documents. But the issue with project-based learning is that all the projects are open-ended. So there's no solution, there's no correct answer for those documents. There's no like expected version for those documents. So so there is a gap from the traditional machine learning approaches to how to make your solution adapt to all the projects. So this is the project I'm working on right now. So how to help the poor instructors. So yeah, I guess my 5 minutes is up, and this is my email, and I will be happy to discuss with you like in the breakout room. Thank you so much.
Thank you, Zhang. Thank you very much. There are a few people I can think of, at least on the UM-Flint side, since that's where I'm from. And so that's who I know that you should connect with, like Mark Allison, he's another presenter here today. Perhaps Cheryl as well, Donaldson, and then Tiago Ferreira, who's somebody, an attendee today. So if you don't see them in the breakout room, then maybe you connect with them, because I think you guys are doing sort of similar or complementary things. So I have a visitor here. Hopefully that's all right. Cheryl is actually our next speaker, Cheryl Donaldson. She is an assistant professor in innovation and technology at UM-Flint. Cheryl, take it away.
Thank you. So, hi, I'm happy to meet everyone. Thanks for inviting me, Heather, and thanks to all our sponsors. And I'll go back into presentation mode here. But as she said, I'm new faculty at the College of Innovation and Technology, and my area of specialty is project management. And just a little bit more about myself, academia is actually my second career. I spent a couple decades working in a family-owned business. We were a small manufacturing manufacturer. We made gear and transmission parts. But that very much informed the rest of my career path. And I went back and got my doctorate in industrial technology from Purdue. And because of my work experience, I've been able to focus on a range of things within manufacturing, such as quality, operations management, project management, technology management, and entrepreneurship. So I tend to float between applied engineering and business. So problem solving is my superpower, if you will, and I look for vendable results, and I also try to help my students do that. So we have students entering the Zillions competition, and I think that's going to be really cool to see where they go out of that, especially as our first year of CIT. So I like to support entrepreneurial activities in academic or corporate settings and global perspective. So I've also accompanied students on study abroad, and we collected data on how students that have experienced study abroad are actually more sought after by employers. So it definitely adds to their marketability in the workplace. So my dissertation was on the progression of underrepresented minorities to graduate school in technology. And from there, it spawned a couple other studies because I also looked at some of the challenges of first generation college students, especially in STEM fields of study. So the major findings were in this study that a lot of the underrepresented minorities finished undergrad with sizable student debt, usually higher than their non-minority counterparts. They were uninformed about graduate school, about the value of it, how funding can be how they can be funded and the structure. And they were also underinformed about the value of research skills and have basically been socialized to work. And so the long-term unintended consequence of this is we do so well in preparing them for undergrad, they're less likely to come back and do graduate degrees in technology, which is affecting our pipeline of teachers, obviously in STEM, as well as professors, because they will not have advanced degrees. We also found that if they had a bachelor's in the STEM field, they tended to wait and go get an MBA at their employer's expense. So now we're looking at how we can get students that are completing undergrad in the STEM field to continue on to graduate school to meet some of our pipeline needs. So that's one major area for me. And so that's part of my current research. I'm also interested in Industry 4.0, additive manufacturing, and digital enterprises. And this taps into my supply chain background and marrying supply chain and manufacturing. And from there, I'm also interested in how we can take these technical advances and create new businesses. So entrepreneurship is my other area. So I wanted to give you a broad overview of who I am, what I've done, and what I'm interested in doing next. So if anyone is interested, please reach out to me, let me know. Most recently, my last paper that was published was on using Lean Six Sigma techniques in cardiac care. So some nurses approached me at my previous institution about cutting the time of response in emergency situations for cardiac patients and using Lean Six Sigma techniques to reduce that intervention time to save more cardiac muscle. So my range is fairly broad, but it stems from an applied technology focus. So happy to be here and looking forward to meeting more of you. Thanks.
Thank you, Cheryl. And I know there's people here that are interested in, of course, increasing that STEM pipeline, just like you, and then just entrepreneurship as well. So thank you for introducing yourself and talking about the work that you do. The next speaker we have today is Samir Rawashta, an associate professor in electrical and computer engineering at UM-Dearborn. Samir?
Samir, can you unmute?
Yes, can you hear us now?
Yes. Yeah, I'm muted, and then like we clicked at the same time. I muted me again. Anyway, so thank you very much for the invitation to speak today. And again, let me know, does the screen appear okay on your side, my slides? All right.
Yes, it does.
So my name is Samir Rashid. I'm a faculty member in ECE department, like the computer engineering department. And so this slide kind of summarizes my background. My core background is actually in embedded systems, so developing microcontroller systems and networked microcomputers that we looked at, for example, in this project at networking of ECUs in a vehicle, given the new demands for high data rate type sensors, and maybe so like Ethernet backbone with Wi-Fi as a backup, and kind of concepts like that. And I've kind of sought over the past 10 years or so, I've sought applying my background at different domains. And one of them that I'm excited about is digital health. And I know Flint has a physical therapy department or faculty. So this is what's kind of shown here is my current NSF project on building a physical therapy assistance system. So using wearable sensors and a tablet app to program in exercises in the clinic that are very specific to the patient and their current ability and what they need to do next. And then it assists them to do those exercises at home to the full range of motion and the correct plane of motion and the correct count as well. In smart health, I have a current project that I've written up over the summer for respiratory health. So it kind of inspired by COVID potentially, but also that applies to COPD, asthma, and any certain lung condition. And the idea is that we wanted to fill the gap of the lack of kind of at-home assessment for lung health, right? You can get your blood sugar measurement, you can get a blood pressure measurement, but there's nothing to get a score for your lung health. And we have some concepts towards that. The remaining here are in the robotics area. So I'm very interested in machine vision and robotics, so perception problems in robotics. So we've developed a visual odometry algorithm, we've developed a multi-object tracking algorithm. And in perception in the past few years, AI and deep learning has played a big role. And we looked at kind of semantic segmentation and other certain tasks. And I'll talk about adverse weather conditions in the next couple slides. We also have some interesting robotics equipment that I'm interested in discussing in potential collaborations and start some potential collaborations. So our new building, we have a few Omron robots, mobile bases, and also robotic arms. We have this NSF sponsored humanoid robot. This one is just a pet robot that chases my kids that we put together for my class as a case study. I think I have another 2 minutes left. I have 3 slides. I've picked kind of some of the exciting results recently. So my PhD student just graduated, and we looked at rain. And a problem with rain is the problem with AI in general is that it works really well for the scenarios that it's been taught to deal with, right? And can you really train? Can you really set up an AI to deal with any lighting condition, any weather condition, and so on? So we tried to kind of push that boundary and look at making vision systems, automotive vision systems, robust to rain. And you can kind of see here that this object detector suffers when the lens gets wet. So we quantified that, and that was kind of very interesting. So what we did was we created a rain simulator. So this was a state-of-the-art, kind of as good as rain simulators get at that moment. And this one's ours. And you can kind of see that it kind of flips the scene inside. It has a little lens effect. It's very realistic in my opinion. And we were excited about that. This one's a video, and you can kind of see the little raindrops coming in over time. And the motivation here was, why do we create a rain simulator? Is that now we can take a data set and artificially augment the training data set. So you drive around and you use your AI for whatever task you're training it for. And then you can synthetically add rain to that data set and then feed that in as well. That we have actually shown in an interesting paper that recently published that actually makes the algorithm more robust to real rain. So we got a real rain data set and to improve the performance on real rain. So our synthetic rain was realistic enough to convince the AI to perceive real rain correctly and deal with real rain. Finally, I wanted to kind of give a pitch that I'm kind of taking on the role of the director for our AI center. So I'd be happy to discuss that. So if, I mean, I'm interested to hear from faculty that work in AI, but also faculty that work in other domains where AI could play a role, right? So AI has the potential to disrupt a lot of fields. And if it might pertain to yours, you know, we would be happy to have you present and we meet faculty and potentially brainstorm some interesting projects and proposals. So I've left my contact info there if you'd like to reach out. And with that, I think that's time. I think I'm 30 seconds over. Thanks.
Oh, you did wonderful. Thank you. And all right, so you have a very broad base of research as well. So I guess thinking about U of M-Flint faculty that may be able to connect with you with ideas. So Mark Allison's our next speaker, for example. He's an AI. Minhu Hung, she's in physical therapy, and then Yasser Abul Qasim in bioengineering. Those they're both here in as attendees today. So if you don't see them in the breakout room, I would suggest sort of trying to get a hold of them, and I think there's ideas there. And there are other people probably at U of M-Flint that I'm not mentioning that I just don't know. But so I think there's a lot of opportunity for sure.
Yeah, it's an open invitation for sure. So the plan is to set up like every other week lightning talks where we can brainstorm and meet and kind of get some exciting projects started.
Oh yeah, so the AI Research Center would be doing something like that. Is that what you're saying?
That's the plan. Yeah. So I'm starting like I started 2 weeks ago. So we had a faculty leave, and I'm kind of taking on this role moving forward.
Oh, well, that's all right. It sounds good. Yeah. So definitely listen to the next speaker for sure, and then connect with some people at the breakout sessions. It's exciting, very collaborative stuff.
Sounds good.
Mark Allison is the next speaker. So he's an associate professor of computer science at U of M-Flint, and he does all kinds of stuff. Even Mark and I have done work together, and I'm a biologist, so he's also very broad, like we've seen a lot from some other speakers. So go ahead, Mark.
Great. I just want to thank the sponsors, and I think this is such a great idea to bring everyone together. So without further ado, let me share my screen. Can you see?
Yeah, we got two screens on top of each other.
Okay. Oh, the computer guy, right? Is that better?
Yeah, that looks perfect.
Excellent. All right. So as Heather said, I'm very broad, and you might ask, you know, how come I am so broad? And the reason being is a long story. So what I want to try to do is to frame this talk into one, the expertise that I can contribute. And then next, I'll talk about some of my ongoing projects to see if I can get some help, right, into getting this work moved forward. And a lot of my collaborators are here, so this is a great opportunity. So at the left, you will see that my PhD is in AI, a combination of AI and model-driven software development. What model-driven software development is, it's a paradigm shift away from programming with text. So pretty much it's visual. It's using visual models, looking at how they interact, and then derive behavior. This combined with AI is an excellent tool to tackle complexities, right? that are constantly being demanded of software. So I did a lot of work in what's called cognified software systems, and found that a natural fit for that would be in autonomous systems. And I started out some work in drones. And funny enough, it was in order for me to fly a drone on campus, I had to fill out like 50 pages. So my workaround was to use AUVs, right, underwater. And then there's Heather doing all this underwater work. It was such a great compliment, and Heather continues to teach me about the biology domain. So I mean, it's great. So coming off of sabbatical, I spent like a significant amount of time being immersed in robotic systems, and so I had some background in human factors, right? A little bit of psychology, especially in the area of what's called affective computing, how to detect emotions and how to portray emotions in systems. And it was a really nice complement to human in the loop robotic teams, because when autonomy is out there working, right? A bunch of robots out there working, they work best with a human collaborator, not a operator, right? At the peer level. So when these teams experience novelty, they need to rely on the human, but they need to know what the cognitive state is. The human drunk? Is the human tired? All these things need to be factored in. They could probably make a better decision, right? So there's a lot of interesting research questions deriving from this, and it's become a passion now. So let's. What I want to do is talk about some of the projects here. So the one that I have a virtual learning infrastructure project that I'm trying to breathe some new life into. It regards, and it's more pertinent now since COVID, right? It's pretty much, imagine Blackboard, but for, but more lab focused, getting projects from the community, right? Having undergrads and K-12 working on different aspects of it at the same time, right? And producing artifacts for the community. So they're working on, it's experiential learning, problem-based. The other aspect of it that, again, the AI human factors coming in is the cognitive load. So there's going to be some scaffolding based primarily on how much effort, mental effort, is realized. So the scaffolding thing, any kind of learning that occurs will necessarily need to be chunked, right? And there's thoughts of having some kind of a recommender system that is based on your personal preferences or observed preferences, right? So pretty much a tailored learning experience. Second one, this is an old project that I have that seems to have a lot more interest in it, have a lot of life breathed into it with recent developments with deep learning, etc. So what it is, think of think of Siri with a body that can express emotions, right? That can recognize and express emotions, and has ethnic considerations or cultural considerations, right? Because once you bring in emotions into become a factor, that different nationalities, different people have nuances, cultural nuances as to emotion. So if you want that realistic portrayal, it's necessary that you would have the that component. And then lastly, right, back to the human robotic teaming. And Zhang, funny enough, I was on a team over my sabbatical, and they were talking about edge computing and how it will work with robots and teams. And well, of course, I don't know a lot about edge computing, right? But I was thinking about this new concept called federated learning, right? Where the swarm increases the learning of each individual item. But the problem is there's a heavy computer overhead, right? Computational overhead. And someone suggested edge. You guys will do edge. You have a way to move around computation very effectively. So we might have to talk. Yeah. And with the rain, the vision with the rain, that was awesome. So that's one of the challenges that Heather and I thinking about, because if you're dealing with underwater vision, right, to look at fish or identify fish, and some days you have bad days. I'm no biologist, but I know when it rains, it gets murky, right? So how do you identify? How do you identify activity down there? And one approach was to see if we could blend sonar and vision systems. And you know, the work is there. All right, I'll stop here. I think I went over 5 minutes. Hopefully not.
Hey, all right, Mark. Thank you. Yeah, I mean, people might go a little bit over, but hey, that's all right. I think we're doing fine on time, right? And there's a lot of really cool work that people are talking about. And I think most of the speakers have been able to like combine both, either AI, computer science, mathematics, or manufacturing, along with educational innovation. So it's a pretty big feat. So it's been pretty exciting to watch so far. So we have another speaker, Song Hong, professor in early childhood education from U of M-Dearborn, and you have the floor.
Okay. Hi, everyone. I'm happy to be here. My excitement is growing about this interdisciplinary work. Okay, so I'm an early childhood professor at the Dearborn campus. My talk is about educational innovation, cycle of inquiry system. The cycle of inquiry system is a tool for early childhood teachers to plan curriculum in response to children's inquiry. It draws on children's natural sense of curiosity, questions, and their theories in relation to their experience. It embraces the ways children learn best. So my research partner, Dr. James Broderick, and I have developed the cycle of inquiry system and published numerous articles about the cycle of inquiry process and its impact on teacher development, and published a book titled From Children's Interest to Children Thinking, using a cycle of inquiry to plan curriculum in 2020. In 2021, the book was recognized as the best product for critical and higher order thinking in the field and received a Smart Book Choice Award by Academic Choice. So I will briefly explain about this cycle of inquiry system and then tool we have developed. So the cycle of inquiry process involves, in the left slide, the cycle of inquiry process involves 6 phases of teacher curriculum planning thinking. As you can see in the right slide, each of these phases are developed a form for teacher to document their thinking, planning thinking. So in the cycle of inquiry process is like the careful observations are the first component of the cycle of inquiry process. And then the second phase, interpreting thinking, teacher reflect on in their detailed observation of children and identify children's thinking as an essential part of their curriculum planning process. The third phase, curriculum action plan, is using children's thinking data from the second phase to frame curriculum questions in diverse ways. The fourth phase, inquiry provocation plan, teacher can design curricular extensions that link to and support children's thinking and inquiry. And then phase 5 is a setup and facilitating the plan. And the phase 6 is reflecting on the children's learning and teachers' teaching practice. So the cycle continues to build on the learning in depth, allowing teachers and children as a co-researchers engage in learning. So if you're looking at the cycle of inquiry tool was these forms and tools in the right are developed through many years of research and have a measurement tool that support the teacher development from novice to reflective to meta-reflective level of planning practice. I'm gonna probably move on to the next slide. So in a sense that, we ask teachers to become a teacher researcher. In the next slide, I thought about, how, how a cycle of inquiry can be, connecting with the interdisciplinary research. So the cycle of inquiry developed based on how people learn. So National Research Council conducted a meta-analysis research on how people learn, and they found that children learn through the same process that guides scientists in their research practice. And this led to development of a next generation of science standard as a framework for K-12 science education. So this process also is aligned with our cycle of inquiry system practices. So many early childhood preschool teachers want to implement an inquiry approach nationally, internationally, but majority are limited by prescribed curriculum that doesn't allow for inquiry learning. And then our next phase of the research is about an app development, like tablets and app development for our cycle inquiry tool for tablets, phones, and computers. And that's what this is part I'm very excited about, because when I first invited to talk, I thought that nobody would be interested in my work. And then suddenly I was talking, I really think deeply about what I want for this collaborative work. And I kind of felt that, oh, there are ways to do some really interesting collaborative work. So again, app development is one of my research agenda for next phase. And then the other part is that by doing that, app allows ease to use, accessibility, so that we can to study broader preschool population to validate this inquiry approach further and to make it acceptable to administrators and administrators. And then the other part is that also this is not only applied to early childhood field, the teacher planning thinking process. So it can be, by doing that, can start this cycle of inquiry approach first with the pre-K third grade, and then move to the grade 4 to 8 and 9 to 12. So it's more like very interdisciplinary approach to our curriculum development. So another project I'm working on is like developing an online professional development learning site so that can grow to assist teachers nationally, internationally. So the work has already started, but I think we need some more other field of support to make that happen. So another part I talk about is that, how psychological inquiry development research can benefit other fields. So some of the questions I thought that, the AI or computer science can get insight into educational practice that can be enhanced and supported the researcher. And then also another research area from the other discipline can be, tool development research. So how does a tool support the teacher efficacy with the teaching inquiry? And how does the tool aid in inquiry research in early childhood education? So also I thought that probably other fields can come up with more research questions. And then my previous work, I actually had some transitional research with researchers in mental health field. So what I know is that by doing interdisciplinary research, always create some innovation and also like generate a lot of new ideas to further research. That's my previous experience. So I decided to, again, possible research focus each discipline. So I don't know much about computer science and AI, but I was really that's why my excitement has grown, because of listening about what other people do. I can see there are a lot of interesting possibilities out there. So I'm really looking forward to work with people who can, benefit each other. So thank you for inviting me for this talk.
Thank you. Thank you very much. That was actually, as the last speaker, you did a great job in sort of making us think about educational innovation and how it works with, right, potentially with computer science and artificial intelligence, which just brings together all of our topics here today, right? So thank you.